Alright, in this video we're going to be taking a look at a yeast sample and calculating its density and viability. So you'll need a sample of your yeast slurry, a beaker for dilution, your hemocytometer, a counter, and some pipettes, and your viability stain. Diluted samples make for easier counting, so in this case I'm diluting a 1 milliliter slurry in 99 milliliters of water. Stir to make sure you have an even consistency. Here I'm drawing up 1 milliliter of slurry, wiping the outside with the Kim wipe, and mixing it in with my water. Now that I've done my dilution, I want to mix it with my viability stain. Whether you're using methylene blue or trypan blue, it's recommended that you do a 1-to-1 ratio with your sample and your viability stain. That makes my total dilution 1 to 200. Give your final sample a little swirl, and then take some up in your pipette for the hemocytometer. I fill both chambers of the hemocytometer and then do an average to ensure accuracy. If a small amount of liquid makes its way into the reservoir in between the two chambers, that's okay. If it fills the whole thing, you'll want to try again. Set your microscope to the 400x magnification to begin your count. You'll be counting 5 of the square grids that you see under the scope. Start in the upper left-hand corner for your first count. Use a consistent sweeping pattern for your count to ensure accuracy. You will only count cells touching 2 of the 4 sides. I use the upper and left sides. So for the first grid in our count, I counted a total of 21 cells, with 5 of them stained blue. Now we repeat the process in the opposite corner. After you've counted all 5 squares, you're ready to do your calculations. A simple ratio of alive cells to total cells gives you your percent viability. To calculate cell density, you multiply the total cells by 5, then by your dilution, and then by 10,000. This sample has a density of 1.4 billion cells per milliliter. And that's it. Now you're ready to enter your figures into your pitch rate calculator.